Hi everyone, welcome back to MacroLearning. So we're still in the alkanes part of the organic chemistry part. And this question is about conformations of alkanes and Newman projections. Okay, so draw all the possible staggered and eclipsed conformations of butane using Newman projections and arrange them in order of decreasing stability. Okay, so conformations are about stability or energy. So hope you still remember what staggered and eclipsed conformations are. Basically, staggered ones are where the front bonds and the back bonds are like 60 degrees from each other. In other words, the bond in the front would bisect the angle in the back that's formed by two bonds. So this bond is in the right middle of the angle formed by these two bonds, and the same goes for this bond and this bond, everything. So this represents, this is typically the lowest energy conformation for a alkane. Eclipsed ones are where, the bonds are just eclipsed with each other like that. They're aligned with each other, front and back. So these are typically the highest energy or the lowest stability of all the conformations. So given that, and we're asked to draw only the eclipsed and staggered conformations of butane. So butane is I'm drawing out the CH bonds for these two carbons in the middle. Okay. To make it easier for us to transform it into Newman projections. So one of the Newman projections or one of the conformations will be let's draw the back one first, corresponding to this whole group. So imagine you're looking to the right along this bond. Okay. So in the back we have this whole group. Would say the methyl group on the top and two hydrogens here and there. In the front, let's draw a staggered to begin with. Let's put the methyl group in the bottom, opposite to this other methyl group in the back, and these are the two hydrogens. So this one in the front represents this whole thing here. Right? Okay, that's one of the staggered conformations. And so to get the other conformations, staggered or eclipsed, what we do is we turn one of them. Turn the one in the back or in the front. So personally, I would keep the one in the back fixed. Okay? Same thing. Methyl, hydrogen, like that. So the back one is unchanged, and we change the front one, and what we do is we turn it by 60 degrees a time. 60 degrees a time clockwise, So by doing that, the methyl group will turn by 60 degrees. It will end up here, overlapping with this hydrogen, and the two other hydrogens will be, that's not perfect one, here and here, right? So that's a eclipsed. So by turning 60 degrees a time, you get staggered, eclipsed, like that. Every other one. So it's one of the eclipsed conformations. If we keep going from there, again keeping the back bonds fixed, and turn the front ones again by another 60 degrees. So this methyl then will be here in the middle of this hydrogen and this methyl in the back, and 2 hydrogens of course will be in these 2 positions. And this is of course a staggered this time. And if we keep going again, keeping the back one fixed, and turn it again by 60 degrees, then wow, these 2 big guys will be overlapping with each other this time. But 2 hydrogens here and here. Okay, another eclipsed. Another eclipsed conformation. If we keep going, still keeping these fixed, and turn the front ones by another 60 degrees. So if we turn this, the methyl would end up in here with these 2 hydrogens here. And if we do it again, by the way, this is staggered this time. If we do it again, only turning the front bonds, right? Then the methyl would end up here. The hydrogen will be here, and the hydrogen here. Okay, so this is another eclipsed. And so that's all, because if we keep going another time, we'll be coming all the way back to this starting one. So this is all we have. This is all the possibilities for staggered. Listen, for only staggered and eclipsed conformations, because if you talk about other conformations, they're just, you know, limitless. The possibility is infinite. But when it comes to staggered and eclipsed, these 6 are the only possibilities we have for butane. But the answer is that there are only 4 of them. 2 staggered and 2 eclipsed. But now we have 3 staggered and 3 eclipsed. So what's happening here? So the answer is that there are 2 of them that are duplicates of some other ones. There's 1 eclipsed and 1 staggered that are duplicates with one of the rest. So which are they? So which pairs are the pairs that are duplicates to each other? Let's see. Now I can see that this is duplicate of this. Alright, so because of that, we only include one of them and get rid of the other one. We can just leave any one of them, either one, and remove the other one. Or we just count one of those to be another new conformation. The other one, it's same as it. So we don't count it. We just disregard it. There's another pair that are duplicates with each other. So what are they? It's this one and this one. So this one is where the 2 methyl groups are like 120 degrees to each other, right? And this one also is where the 2 methyl groups in the back and front are like 120 degrees to each other. So these 2 are the same too. These are also the same. And okay, so we have these 2 that are duplicates of these 2, so to speak. So we just do not have to include these two as other conformations. So we only keep total of four conformations, 2 staggered and 2 eclipsed. Actually, you know what? I personally do not agree with the point that these two are really the same conformation. It's what the textbook tells us. It's what the professor would teach us about. But personally, I still think they are kind of different. If you look at them closely, you'll find that they're like mirror images to each other. The two circled in red, right? They're not overlappable with each other. They're mirror images, like your right hand and your left hand. So would you say your left hand is the same as your right hand? Probably not. So why are they considered the same conformation? Because they have exactly the same energy. Stability-wise or energy-wise, they are exactly the same. So they're considered exactly the same conformation. It's kind of a maybe not a subjective thing, but I think it's kind of a definition thing. How you define being same as each other, how you define that, or it depends on how you feel. But anyway, it's the textbook that says that these two are the same conformations, and the professor will tell you the same. And in your exam, that's the important part. In your homework or exam, you want to just include one of these two because the textbook says only one of these counts as another conformation because these are duplicates. But in my personal opinion, they are not exactly the same. They're the same energy-wise, but not, they're just mirror images of each other. I would call that really the same. Same goes for the two ones circled in yellow. They're mirror images. They're exactly the same when it comes to the stability or energy. But strictly speaking, I wouldn't call them exactly the same conformation. But again, textbook-wise, they are defined as the same, as duplicates to each other. So anyway, we can just cross out any one of these in either one of these in the red, either one of these in yellow, but let's cross out only the ones on the right hand side. Let's see, eraser, okay. So we end up with 2 staggered and 2 eclipsed conformations. Okay. And when it comes to energy, which ones have the higher energy and which one have the lower energy? So what we know is that the staggered conformations, these two, are always going to have lower energy or higher stability compared to the eclipsed conformations. That's the bottom line, right? So these two are definitely going to be number 1 and number 2. So which one is number 1, meaning the most stable one? This one is going to be the most stable with the highest stability. I've called it number 1. Lower number representing higher stability or lower energy. Because these two big methyl groups, are farthest away from each other, as far away as possible from each other, so the energy is minimized. So this is the least strained conformation, so it's got the highest stability, most stable. So the next one obviously is going to be this, because whatever it is, staggered conformations always are going to have much better stability than the two remaining ones, the 2 eclipsed ones. So 2 eclipsed ones are going to be number 3 and number 4. So which one is number 3 or number 4? I would say number 4, the lowest stability 1 will be this one, because the two methyl groups are so close to each other, or as close to each other as possible. So they're really kind of overlapping. That creates a lot of strain, and causes the molecule to be very unstable. The least stable one is thus this one, and this one is actually obviously going to be number 3. So 1, 2, 1, 2, 3, 4. So this one has got highest stability and lowest energy, whereas this one here, where the methyl groups can't be any closer, they're really close to each other. So that creates a lot of strain and causes the stability to really suffer. So it's got lowest stability. Okay. And higher stability corresponds to lower energy. You know that. So, okay, that's it for this question. Again, if you have any questions, any thoughts or suggestions or doubts or comments, anything, just let me know by emailing me or calling me. And don't forget to subscribe to my channel and visit me at MacroLearning.com. Okay, thank you so much. Have a good day. See you next time.